Hi, welcome back. This is Rakesh Naik. Today we are going to discuss about linked list. But before we start, one information I'd like to share. In this channel, we produce every video in two different languages, Hindi as well as in English. So if you want to watch this video in Hindi, kindly follow the link given in the description. And if you have not yet subscribed, kindly press the subscribe button followed by the bell icon so that you will get all the updates from this channel. So let us start linked list. So before we start linked list, let us try recall the disadvantages of array so that it becomes easy for you to realize the advantages of linked list. If you remember, array, it is a static data structure. It means at the very beginning, at the time of compilation itself, we need to define our array. The size must be fixed throughout. We cannot change it at the runtime. Secondly, it is inefficient kind of a data structure because it needs a lot of data movement. Whenever we are inserting or deleting some data, it needs a lot of data movement. Because of its simplicity of array, it is possible that we are trying to access some data which is beyond the scope of this or beyond the range of this particular definition of array. The last disadvantage is poor utilization of space. When we are defining an array for a name, we can take the size 20 or 25. When we store a small name, then rest of the memory become wastage. So these are the disadvantages that we have with array. So before starting linked list, I hope you have heard about this game called treasure hunt. It is a very interesting game of treasure hunt. In this game, a team member is provided the primary hint of the first locality. From the first location hint, the participant get the second and so on. To reach the final stage, the participant has to go through each and every locations in the specific order. Even if the order of one of the location is wrong, the participant will not obtain the clue for reaching the next location, and hence the player will not be able to find the destination, the treasure. So this is what we are going to do with our linked list. So the linked list is a linear data structure which is the solution to overcome the problem in array. And linked lists do not necessarily contain the consecutive memory location, and the data item can store anywhere in the memory. A linked list using dynamic memory management follow the principle that allocate the memory when you need it and release it when the work is over. To maintain the specific sequence of these data, we need to maintain the link between the successors. So this is the basic concept. If you understand this, then linked lists become easier. In order to maintain the specific sequence of items, we need to maintain a link with the successor. It is called a linked list as each node is linked with this successor. Single linked list is ordered list which contain collection of nodes, and each node contains two parts. The first part is contain the data element and the second part contain the address of the next node. Here you can see in this particular diagram, if we say this is a node, then the first part contains the data and the second part contains the address of the next node. Let us see an example. Let us say the operating system assigned this 116 as my starting address. So let us say in this particular location, I save the data A and I don't know my next location now. So when my next location will be allocated, at that time I'll keep the address instead of null. Let the next location be 32. The data saved here is B and its link is null. You can see here for A, the address of B is kept here. 132 is the address of this particular node, and to follow A, the address 132 is written here. Similarly, you can check if at 124th location data C is present. So B's next becomes 124 and C's next is null. The second parts are my links and the first part are my data. Similarly, if I want to add D, let us say at location 108 it is allocated. The data I kept as D. The link of C is written as 108. It means I'll reach C, go to the address 108, and at 108 I'll find D. Similarly, all other data I can start. It means, as the example in the treasure hunt, I'm starting with A. I got A, go to the link 132, and from 132 I can go to B, and in B I got the address of C, that is 124. I can go to 124, find the address of C, then I'll get a link 108, and at 108 I'll find a D. So this is how I am going to traverse, and this is what I am going to implement in C++. Only one thing to remember, only the first position is given. We cannot refer to the third or fourth node directly. Only the link attached to the second node can be indicated where the third node is, and the second node position is available at the first node's link. Hence, we get the ith node, we have to go to all the nodes in the sequence. It means I have to go to node 1, then node 2, then node 3 until I minus 1th node. Unless and until I complete I minus 1th node, I will not be able to go to the ith node. So let us see what the linked organization refer to. The basic features of linked organization include the following terms. The elements can be placed anywhere in the memory. The dynamic allocation, that is the space allotted as per the need, and it can be done at the time of execution. And the nodes are not placed in consecutive memory location at a fixed distance apart. Random access to these elements are not possible. Insertion and deletion of the objects do not require any data shifting. Every element keeps the address of the successive elements in the link field, and only the burden that we need to address is the space for the link field for each element. However, the additional space is not severe penalty when large objects are to be addressed. So these are the basic linked organization features that we are having. For our better understanding, let us try to see one example. Here at 116 location data, it contains A, and it is going for look into 132 location. At 132 location, data B is available and it will look for 124 location. So like this, so in order to have a linked list, there are few more important things that we need to discuss. We need a pointer. The first pointer that we need is called a head pointer. The head pointer is a variable which represents the list, and it is simply a pointer to the node that the head of the list. The linked list must always have at least one pointer pointing to the first node, that is head of the list. The pointer is necessary because it is the only way to access the further links in the list. The pointer is often called a head pointer because the linked list may not contain any dummy nodes attached to the first position called the header pointer. The first node is called a head node. A header node is a special node that is attached to the beginning of the linked list. The header node may contain special information or some metadata about the linked list. One more special node is that is called a tail node. So a pointer similar to the head pointer that points to the first node on the list, we have something called a pointer that points to the last node of the list. That is called a tail pointer. The list contains data nodes that store the data members, and the links, we get the successor from the link of the data node. Generally we define a class like this. So we are having a class node and it contains the public as a character data, a link of node type. We are having one more class called linked list, and we are having a private, that is a node. I am taking a pointer type of head and tail, and in the public part I am having a constructor called linked list, and we are creating a head pointer containing null. And in this video we are going to discuss how to create and how to display a linked list. So basically node of a linked list will look like this. It will be having two parts, one containing the data and other contain the link. So let us see this code, and we are creating a new node which is of type node, and we are putting the data by a cin statement, and we are writing its link to be null. So it will look like this. So a node is created, and in this node we name it as new node. It will be having two parts, one is data, another is link. And in the data part, let us say we kept A, and the link part we kept null. So let us see how to create a linked list. So here you can see the pointer is pointing to a new node. So a new node is created with some data, that is data A, and its link content null. Let us say it is assigned at memory location 1024. And here you can see if head is null, then head is new node and tail is new node. So two pointers we are defining, head and tail, which is pointing to the same node, that is new node. Let us say one more node we created, and we kept the data B and its link content null. So you can come to the else part. Let us come to the else part. Here you can see tail's link become new node. So a link is established, and we are keeping the address in the first node as 1032. That is the address of second node. I will keep it in the as a link part of the first node, and we will shift the tail node to the next node. So tail becomes the next. So tail equal to new node. It means I'll keep the address of new node in the tail. Similarly, again I have created one more node, and it contains the data C. Its link is null, and let us say it is kept at 1040 location. Again I have to come to the else part, and now my tail is pointing to node containing data B. So its link I'll point to the node containing data C, and I'll move the tail to the next node. And like that I'll keep on creating new nodes with data and the link to be null. And the program I'll just consider the else part, where the tail link is equal to new node and tail equal to new node. So every time a new node is created, in the previous node's address part, this new node's address will be kept and the tail will be moved to the new node. And this is how we are going to create our linked list. So you can go through this program. I'm sure you will be able to get how to do a linked list. Let us see. We are taking a variable called answer, and we are creating a new node. While 1 means while true, we are asking, we want to add some more node into it. If answer is no, we'll come out. Otherwise, we'll create a new node, and I'll add this node at the end of the linked list. And this is how I'm going to generate my new node. We have already seen this in our previous slide. And how to add the node at the end, this program is said. We have already seen this with the help of an example. Now if I want to display it what I have to do? I have to start with a temporary node which is pointing to the head node, and if the pointing node is null, then I'll say the list is empty. Otherwise, I'll come to the while loop. It means while the temp is not null, what I have to do? I have to print the data. Here A is printed. Now temp becomes temp link. It means I'll move to my next node. Again, I'll go to while, and in this while loop, I'll check whether the temp is equal to null or not. If it is not null, I'll print the data, and then I'll go to its link, and temp will be moved to the next. And like that, I'll be keep on moving till the temp is not null. So likewise, I'll be traversing or displaying my data. I hope you understood how to create a linked list and how to display data, or a basic traversal technique. So in our next video, we are going to discuss about how to add a new node at a different location. So apart from that, we'll go into the details of traversal. So keep watching, keep learning. See you in the next video. Till then, take care. Bye.